So moving on to properties about natural log, if you go back up and look at the graph, you'll notice that the domain is x greater than 0, so we can say 0 to infinity, while the range goes from negative infinity to positive infinity. And again, if you look at the graph, it'll be easy to see. We also know that it's continuous. One of the ways we know it's continuous, other than by looking at the graph, is because it's differentiable. And if it's differentiable, that implies continuity. That's a reminder. It's also increasing, because if you notice on the graph, the slope is positive everywhere. That's always positive. And last but not least, it's 1-to-1. And remember, that means simply that it passes vertical line test and horizontal line test. And the third thing is that natural log is concave down. Again, if you look at the graph, you can see that. And so therefore we know f double prime then has to be negative. These log rules are just reminders from what you've already learned in a previous class. First of all, that natural log of 1 is 0. If I have a product of two values, I can split it using my log rules into addition. If I have a quotient, I can split it into subtraction. Remember, the numerator value goes first. And if I use my power rule, or I can write it natural log of a just to the b, that means the same thing without the parentheses. But remember, this back from especially pre-calculus, you can bring the power down. So it's equal to b natural log of a. And then some quick examples with e. So if I have natural log of e to the x, I can bring that down, and I'll get x equals natural log of e. And hopefully you remember that the natural log of e is equal to 1. That's because the log base and the value I'm taking log of, these match. And when they match, I end up getting the exponent, which is just a 1. So natural log of e to the x will end up equaling just x. Poof! Magic! And likewise, if I do e to the natural log of x, keep in mind that once again, there's a little tiny e in here. It doesn't show up very well in yellow though, does it? Different color. So I have a little tiny base e in there. And when the exponential base and the log base match, it's like they cancel each other out because they are, in fact, inverses of each other. And so I just get x. Poof! Magic once again. And then just one other formula that you might have forgotten that comes up a lot when we're working with exponentials is both PERT and your compounded interest formulas. So that's the one that people usually forget. I call it PERINT and your PERT formula for compounding continuously.